Right, the last part of this chapter is to work through the process backwards, meaning we are given the answers and then we have to come up with the equation. Now remember, based on the directions determines how we're allowed to leave our answer. So if it doesn't specify the form of our equation, then we can leave it in factored form, which is the easiest. But if it does say standard form, then we would need to simplify everything out so that we are writing it without parentheses from the from the highest exponent to the lowest exponent. Okay. And this is also where it's important to remember that our imaginary and irrational answers come in pairs, so a positive and a negative. And that if we have a multiplicity of something, that's how many times the answer is showing up. Okay. And with however many answers we start with, so if I start with 3, that means that when I'm done, my highest exponent should be a cubed if we were writing out in standard form. Or at the very least, I should have 3 groups of linear factors, or I could have a quadratic factor and a linear factor, because that would give me a total of 3 if we were to finish multiplying it back together. Okay. So we're just going to work through some different scenarios for those types of problems. Okay, so as I'm looking at this, for number 9, I have 4 answers because this one is showing up twice since it has a multiplicity of 2. So I'm thinking of each of these as equal to x. And if it has a multiplicity of 2, I need to remember to write it out however many times that is. Okay. And then we're going to put it back into factored form. So that means that we need to get each of these numbers on the same side with x. So this will be x minus 3, x minus 2, and then I will have x plus 1, and then another x plus 1. Now, in the directions, this is just telling us to write a polynomial function of least degree with integer coefficients that have the given zeros. So because it's not specifically saying standard form, that means that I can leave it in factored form. So I'm just going to simplify this last one. So I will have x minus 3, x minus 2, and then x plus 1 squared. So this will be my final answer. Now, number 10, it is giving us one of the imaginary numbers. So this is where we need to remember that it always comes in a pair. So even though it doesn't write it, negative 3i is also an answer. So really, we have 3 factors right now. So I have x equals 2, x equals 3i, and x equals negative 3i. So if I'm putting them back on the same side with x, this one would be x minus 2. And then I have x minus 3i and x plus 3i. Okay. Now, when it says integer coefficients, that means that I'm not allowed to have the I there. So at the very least, I am going to need to multiply this pair together. So I'm still going to have that x minus 2. And then if I start foiling, this will give me x squared. And then plus 3ix minus 3ix. Minus 9i squared. So my middle terms cancel, and then that is really a positive 9. So this will be x minus 2, and then x squared plus 9. Now, if you don't want to have to FOIL that, the other way to work through this is to take whatever this is, and when you set it equal to x, we would square both sides. So this will be x squared equals 9i squared. So that's really a negative 9. And then we would add that over to get that x squared plus 9. So that's another way that you can work through this type of problem. So on this one, so again, we're assuming that the negative of our irrational number is also an answer. So I have x equals 0, x equals the square root of 5, x equals negative square root of 5. So really, this is just an x, and I'm subtracting that, so x minus the square root of 5, and then adding, so x plus the square root of 5. And then again, for that integer, I can't have that square root symbol, so at the very least, we're going to have to FOIL that back together. So x times x is x squared, and then I will have x square root of 5 minus x square root of 5, so those are going to cancel. And then negative square root of 5 times a positive square root of 5 is negative square root of 25. And then that x just comes down. So again, middle ones cancel. And then I will have x squared minus 5. Okay. Now this one's similar to what I did for this problem. So again, we are allowed to just think of this as x equals the square root of 5. And then I can square both sides. So that would give me x squared equals 5. And then we would subtract it over to get this. So again, that's just another way to work through this same type of problem. So next one, so I will have x equals 0, x equals 3 plus 2i, and then x equals 3 minus 2i. So again, that always comes in a pair. So that will just give me an x. And then I'll need to subtract the 3 and the 2i. So this will be x minus 3 minus 2i. And then I'm going to subtract the 3, add the 2i. So this tells me I need to multiply that back together. So I'm taking x times everything in this third group. So that will give me x squared plus, minus 3x plus 2ix. And then I'm taking the negative 3 and multiplying it to everything in the second group. So minus 3x plus 9 minus 6i. And then I'm going to that third term and doing the same thing where I'm multiplying it to everything in that last group. So this will be minus 2ix plus 6i minus 4i squared. So as I'm looking at this negative 2ix and positive 2ix cancel. I have a negative 6i and a positive 6i that cancels. And then this is really a positive 4, because remember our I squared is negative 1. So now if I combine, I will have x squared, and then a negative 3x and a negative 3x is a negative 6x. And 9 plus 4 is 13. And then that x just gets brought down in front of it. So this would be my final answer, which is in factored form. Okay. And then that will also conclude this unit.